Hello, geometry students. Today we're going to focus on the Pythagorean theorem and its converse. In Chapter 8, we are working with right triangles and trigonometric functions. So, what is the Pythagorean theorem? The Pythagorean theorem says you can take the legs of a right triangle and square them. You can take a squared, which is a leg, plus the other leg, which I call b squared, and it equals the hypotenuse, which is c squared. Now, some people are probably wondering, where did they come up with the a, the b, and the c? If you look here, angle A, across from angle A is little a. Angle B, across from angle B is little b, and C is our right angle, and across from our right angle is little c. And we'll use this concept throughout Chapter 8. Let's look at our two examples. In number 1, I have a rhombus. I have a right angle there. My hypotenuse is 16. I'm sure a lot of you have already started. 14 squared plus x squared is 16 squared. I would not go ahead and square these numbers, people. Just go ahead and you move your 14 squared to the other side. Now with your calculator, take 16 squared minus 14 squared. That's going to get you 60. Now, what we usually do is we just punch that in our calculator and write our decimal down. In this chapter, part of our focus is on radicals. So we're going to simplify that radical. I like to work with perfect squares. So I'm going to take the square root of each side. X equals the square root of 60. So I'm thinking to myself, what perfect square is going to 60? 4. It's even, so I think 4. 4 and 15. The square root of 4 is 2 root 15. Let's look at example number 2. All right, I have an isosceles triangle here, and I'm looking at the altitude. When you have an isosceles triangle, that altitude breaks the base into two pieces. So this will be 21, and that will be 21. So once again, we're going to use our Pythagorean theorem. X squared plus the other leg, which is 21 squared, equals our hypotenuse, which is 24 squared. Again, I would not go and square those and write those down. I'd move my 21 squared. I punch that in my calculator. 24 squared minus 21 squared. I'm getting x squared to be 135. That's going to get me the square root of 135. Okay, now again, I have to be thinking about simplifying that radical. I see it ends in a 5, so I'm thinking I'm going to take 135 divided by 5. I'm getting 5 times 27. Move that up a little bit. Now when I write 27 down, I think that has a perfect square in it. So I'm going to continue to write root 5. 27 is 9 times 3. X equals square root of 9 is 3. The 5 and the 3 are underneath the radical. That makes it root 15. All right, you can use the Pythagorean theorem to determine if you have a right triangle, an acute triangle, or an obtuse triangle. If you have a right triangle, the Pythagorean theorem will work on it. So if you take the a, the leg, plus the other leg, which is b, squared, and it equals the c squared, then you have a right triangle. If you take the a squared plus the b squared, and it's less than the c squared, then you have an obtuse triangle. And if it is greater, if you take your a squared plus your b squared, and it is greater than your c squared, then you have an acute triangle. Let's apply this to the following problem. Determine whether the following sides can make a triangle, and if it's a right, acute, or obtuse triangle. Now, when you look at this problem, you really don't know which one's going to be the hypotenuse. One thing that you could do is you could take 3 root 2 on your calculator and change that to a decimal. When you do that, 3 times root 2 in decimal form is 4.2. Root 7 as a decimal is 2.6. So now at this point I can tell that 3 root 2 is going to be my hypotenuse. So this is my C. So I'm going to take 4 squared plus root 7 squared. I'm trying to decide equal, greater than, or less than, so I put a question mark over my equal sign. And then I need to square the 3 root 2. So the whole quantity, 3 root 2, needs to be squared. So see how I put parentheses around that? Okay, so 4 squared is 16. Square and square root cancel each other out. You shouldn't have to use your calculator on that. It's going to be 7. I'm still deciding what I got going here. Everything needs to be squared in that parentheses. So 3 squared is 9. Square root of 2 squared, the square root and the square root cancel each other out, which would leave you with a 2. Okay, so my next line, I've got 16 and 7. That gives me 23. 9 times 2 is 18. All right, I'm getting larger than, 23 is larger than 18. So I look back on my rules, greater than is acute triangle. Now you need to show that work, guys. This work needs to be shown in your homework. Pythagorean theorem triples. Those are numbers that work in the Pythagorean theorem. Numbers that work in a squared plus b squared equals c squared. My favorite one is 3, 4, 5. That works, and it is a right triangle. 3 squared plus 4 squared equals 5 squared. 3 squared is 9. 4 squared is 16. That does equal 25. So then I use my Pythagorean theorem, triple, to come up with more triangles. So my favorite one was 3, 4, 5. So now I can come up with another one. I'm going to write 6, 8, and 10. How did I get my first one to my second one? I've multiplied by 2, haven't I? And if you'd like to check that out, 6 squared, 8 squared, 10 squared, it does work. 36 and 64 does equal 100. So I can come up with a lot more Pythagorean theorem triples by just building off of my 3, 4, 5. And I use that quite a bit, so you want to be a heads up on that. That's called being in the same family because they've all come from 3, 4, 5. So let's apply that to example number 4. All right, I see that I've got a right triangle and I've got 2 legs. So I'm going to do Pythagorean theorem to that. My 2 legs are 27. So I'm going to take 27 squared. I'm going to take 36 squared. And my goal is to get x squared, which is the hypotenuse. Now as I'm looking at that, I'm thinking, oh, 3 goes into 27 and 4 goes into 36. Both of those are times by the same thing, aren't they? They're times by 9. So this is my 3. Here's my 4. Over here is going to be my 5. And I'm going to times that by 9 as well, guys. So using my Pythagorean theorem triple of 3, 4, 5, I can find the answer of 45 without even using my calculator. If you wanted to, you could, yes, take 27 squared, take 36 squared equals x squared, and punch that in your calculator. When you take 27 squared and 36 squared, you get 2025 is x squared. Take the square root of both sides. Yes, you are getting 45. But if you can spot that 3, 4, 5 pattern there and realize that they're in the same family, you're going to get that answer a lot faster. You have powerful minds, people. Use them. You guys have a great night, and I'll see you tomorrow in class.